Hi everyone, my name is Anoushka, and the topic that I chose to look into, I guess a broader perspective of it would be chemistry. It was mainly chemistry and a little bit of engineering, not really, mainly chemistry. But specifically, I looked at polypropylene and potential alternatives, and in general, like the future of plastics. So oh, okay, it works. So plastics is something that I've been researching for a little over 2 years now. So I did a big project of mine. It was like a kind of a school project, kind of like a personal project kind of thing, where I looked at the biodegradability of disposable medical masks. And because they have a specific type of plastic that they use, I wanted to look into first of all, the effectiveness of, cloth masks, and then also the effectiveness of those disposable plastic masks and what makes them so different, and why they're polluting so much of the ocean, especially with the rise of the pandemic. So that was kind of the start of this, and I thought that Talaria would be a great opportunity for me to expand on that. So I looked specifically at polypropylene, which is one of the 7 plastics that are most commonly used. And polypropylene is, I chose polypropylene, even though it's not one of the mainly used plastics in the world. Like, if you're familiar with it, HPDE is one of the, like, it's really common in like water bottles and like big, like detergent bottles. It's used like everywhere basically. But polypropylene is it's different because you can't recycle it properly. So people think that you can recycle plastic, like, oh, it's fine, I'll just put it in the recycling bin. But that's not really how it works. So whenever it goes into the recycling, it's called the end of life process, where it doesn't fully go into recycling. It just sits there. So, and even some of the recycling processes don't really go out fully. They're kind of just like left halfway, if that makes sense. So I wanted to look at polypropylene for this reason. So mainly I looked at, similar to the project I did like 2 years ago, I kind of looked at the differences between regular plastics and then also bioplastics. So bioplastics is one of the things that I was also interested about, and kind of seeing the difference between them. So I looked at polypropylene and then bioplastics of polypropylene, and specifically 2 different types of bioplastics of polypropylene, which are one, I really cannot say the name of this. I've always tried. It's polyhydroxybutyrate, or PHB. I just call it PHB. And then the other one was polylactic acid, which is PLA. So those are the 2 that I was comparing to polypropylene. And polypropylene, I specifically looked at, oh, also this is, I also looked at the very specific like chemical molecular kind of details of each of the types of plastics and the bioplastics. So this is one of the bioplastics, this is PLA. I looked at the polymerization of each of the bioplastics and the plastics to see how they would decompose, and those kind of differences, to see what are the similarities and differences, and then also, is it worth having bioplastics in general, or should we look for a different solution? So anyways, as I was saying, I was looking at 3 different types of polypropylene. So I was looking at what's it called? Isotactic, atactic, and syndiotactic polypropylene. And each of these 3 have different tacticity, which is basically how it's in the polymerization process of each of these different types of plastics. So that tacticity ultimately affects the physical properties of those plastics, and that's why I looked at specifically that kind of factor and kind of compared it to the bioplastics. So yeah, basically I just did a compare and contrast, pros and cons of bioplastics, and then also regular polypropylene, and all of the 3 strands of polypropylene. So I just wanted to read my abstract, just to, like, if this doesn't make sense to anyone, like, I feel like my abstract is pretty comprehensive. So Traditional plastics, although widely used, have been proven to be detrimental to our environment and human health in the past years. Due to the abundant use of the conventional plastics, the complete removal of plastics from commercial use is not possible in the near future. Thus, alternatives such as bioplastics have been considered. Among the many commonly used plastics, polypropylene is one of the least recycled plastics. As such, polypropylene poses dangers to the environment, which has motivated work in finding bioplastic alternatives to this conventional plastic, such as PLA and PHB. Herein, the pros and cons of each of these plastics were analyzed, leading to the conclusion that a middle ground for sustainability and sufficient use is difficult to achieve for widespread use in the current available materials. So I basically, going back to like the origins of why I kind of chose plastic, I chose plastic because there are two main issues. Obviously the environment, and then also human health is one thing that people don't consider a lot of the time, because we always think about, oh, we're polluting the ocean and all that stuff, but also this is ultimately going to affect our health as well. So that was kind of the story of why I was interested in plastics in general. So yeah, that was a rundown of my entire project. Then also I wanted to talk about my mentoring experience. I had a wonderful time with my mentor. She was very, very flexible. I loved her so much. She was so great. She actually wasn't really looking into plastics or like, sustainability in general. She was actually looking at metals and stuff, and she wasn't really into this field, but she was so knowledgeable about like, how to get these resources for me, which I really appreciated, even though she didn't have, little to no experience about sustainability and what I wanted to learn about. So yeah, even during the start of whenever we started our meetings, I told her I was really interested in sustainability. And right off the bat, she kind of told me all these ideas. And I was like, oh yeah, I'm not really into like climate change and all that stuff, but like I would want to do something with like biodegradation or something like that. And she was like, oh yeah, that's so cool. I can get something for you. So that was really amazing. I loved her so much. She was so great. So big thanks to her for, guiding me through this. Next, my learning experiences. I definitely had a lot of learning experiences during this process. I think one of the big ones was that I usually write in a way that isn't really scientific. And whenever I wrote my first paragraph, my mentor was like, oh, all of this is so wrong. Like you can't, I usually like go around the bush and like say, make it really abstract about what I'm saying. Like my first sentence, I didn't even mention plastics, like the word plastic. I kind of described it as like a novel kind of thing. So that was fun. But she told me that, hey, you can't do that. You have to actually say like plastics are. So I was like, okay, fine. So that was kind of like, that was a big one for me actually, is kind of the wording and kind of the language that scientific papers use. And also the formatting was something that, I learned about. Definitely that was a challenge. Successes, definitely, I think just my general knowledge and expanding my knowledge is a big success for me. I was really interested. I hadn't really studied polypropylene in the past. I looked at other plastics and kind of like a combination of plastics. I never really looked at one pure plastic. So I think this gave me a bigger understanding of, a more detailed understanding of, how these different qualities and different properties, physical properties, can kind of influence the final product of whatever is considered, like a mask, a bottle, a water bottle, something like that. So that was really interesting for me. Never mind. Closing statements. I just wanted to say, this is a great opportunity, a great learning experience for me. I learned so much. And I hope we can do something with this, or I can do something with this, because I've had a lot of projects going on with plastic in general, and this definitely I think will help me to get more detailed about what I'm doing, because a lot of the work that I've been doing is kind of just ideas about, how can we make these plastics more sustainable and everything, but now I know it from a more molecular level. So that was really cool. So yeah, thank you so much. And I am open to any questions.